Hey folks, how y'all doing? We've got a very short video today. We just have a couple things to wrap up, and this will be the last video in our series. Let's get started. So we have a couple of definitions that are not in our textbook. We're using a pilot book this semester, and they do appear in the David Poole text, which is the traditional textbook that we're using for this course. And just to be thorough, I'd like to cover them today so that in case they show up in the question of one of the final exams, you won't be thrown by a term that you haven't seen before. Excuse me. So I want to go ahead and show you these two definitions. They have to do with linear transformations. Um, so a linear transformation, remember, is a function that sends a vector x to the result you get when you multiply that matrix times multiply a matrix times that x. So it sends x to a linear combination in which x is the coefficients in that linear combination. So this is a vector, this is a linear combination. Um, and we say that linear transformation is onto if anytime I pick a vector y in the range, the equation t of x is equal to y is consistent. Um, that is, I can always solve this equation and I never get an inconsistent system. Well, what that means is that ax equals y is always consistent. And that means that when we augment with x, no matter what, augment with y, because we're trying to solve for x, we always get a solution, which means we cannot have a leading entry in this column. And that means that we must have a leading entry in every row, which would block leading entries from this column. And therefore, A has a pivot in every row. And so T is onto is another way of saying that the columns of A span R to the M. So it's just another way of saying something that we've been using the idea of spanning sets. The term onto is another way of saying that sort of same idea. And here's the other definition. I said this was going to be short. We just have two definitions to clear up. A linear transformation is one-to-one if every time I take two different vectors in Rn, so a vector x1 and a vector x2, then the transformed version of those vectors are also different. So what we don't have is x1 and x2 both going to the same vector. That would be then 2-to-1 instead of 1-to-1. So 1-to-1 says if my vectors are different in the input, they are also different in the output. Well, another way of saying that is that if I look at a vector in the output, it cannot have two inputs that get to it. It cannot have two solutions. Because if x1 was a solution and x2 was also a solution, then t of x1 would equal t of x2. And so the system of equations cannot have more than one solution. And so the system has no free variables. And so A has a pivot in every column. And we know what pivot in every column means. So saying that t of x is 1-to-1 is another way of saying the columns of A are linearly independent. Um, and so again, neither of these terms introduce something that we haven't covered before. We just used different terminology when we talked about it. So, um, but now you're familiar with both sets of terms, and let's do one example, and then we will finish up this video. So we have a matrix A, and that's the matrix that generates this linear transformation. A is the matrix below. Let's determine whether the transformation is 1-to-1 or onto. So we're going to want to row reduce this matrix. So first step I might do would be row 1 minus row 2. That's going to give me a 1 in the top left corner, 7 minus 6. 5 minus 7 is -2. 2 minus 2 is 0. All right. Now I'm going to try to make these two entries into a 0. So I'm going to take row 2 minus 6 row 1 and row 3 minus 2 row 1. Six minus 6 is 0. 7 minus -12 is 19. And 2 minus 0 is 2. Two minus 2 is 0. 3 minus -4 is 7. And 1 minus 0 is 1. All right. Well, let's keep going. Let's take, is there a way, easy way to get this 19 down? Let's see if I take row 2, let's see, and 21. That's not going to do it. It's going to take 3 row 2 minus 8 row 3. Let's try that. This is a little weird. 3 times row 2 is 3 times 19. That's 57. 8 times 7 is 56. So 57 minus 56 is 1. 3 times 2 is 6. 6 minus 8 is -2. All right, 0, 7, 1. And then we'll take row 3 and subtract 7 times row 2. So we get 1, -2, 0, 0, 1, -2, 0. 7 minus 7 is 0. 1 minus -14 is 15. All right. This is in echelon form. It's not in reduced echelon form, but it's enough for me to know that I have a pivot in every row. And that means that T is onto, and pivot in every column. T is 1-to-1. So, in fact, T is both onto and 1-to-1. And now we have covered the two definitions that are in the pool book and not in our pilot book. And that is the end of the videos for the course. Thank you for sitting through the whole series. And good luck on test 3 and good luck on the final. Y'all take care.